Now let's go through a couple of examples of the initial value problem. Okay? The first step here is to rewrite this differential equation in the right form, where the left-hand side contains both y prime and y. So the left-hand side is y prime minus 2y equals minus t. Then we need to find the integrating factor. So the integrating factor is mu of t is e to the power the antiderivative of the coefficient at y. The coefficient at y is negative 2 dt. So the antiderivative of negative 2 is negative 2t. Right? So the integrating factor is negative 2t. So then we multiply our differential equation by e to the negative 2t. So we get to the negative 2t y prime minus 2 e to the negative 2t y equals minus t e to the negative 2t. Well, but then notice that the left-hand side is now the derivative. Well, of course it is, because that's the what the general method tells us. So it is the derivative of e to the minus 2t y prime. Well, but then it means that, well, we can think of this as e to the minus 2t times y being another unknown function, and its derivative is minus t times e to the minus 2t, which means that e to the minus 2t y equals antiderivative of minus t e to the minus 2t dt. Now, of course, I could proceed and find the antiderivative by integration by parts, but integration by parts, I hope, was learned in year 1 calculus, and I don't need to review it again. And I'm teaching the theory of differential equations, so we can skip this part and we can just do it in Wolfram alpha. All right. So integrate minus t times minus 2t. Yeah, I recommend that if you are sure that you are not going to make stupid mistakes in integration by parts, if you don't need any extra practice in integration by parts, then you just skip it whenever you do homework, and you can just compute it in Wolfram alpha. So here is the answer. And so this is 1/4 e to the minus 2t times 2t plus 1 plus constant. Now, recall that when we did separable differential equations, then we would find the value of the constant right now. With linear differential equations, it doesn't matter, so we can do it later. So we can solve for y first. Y equals multiplied by e to the minus 2t. We get 2t plus 1 over 4 plus c e to the 2t. Okay, now we can find the constant. So now let's look at our initial condition. It tells us that t is 0 and y is 1. So 1 equals, t is 0. 0 plus 1, 1/4, plus constant, and e to the 0 is 1. So our constant is 1 minus 1/4 is 3/4. Finally, we can write the final answer. So the final answer is that y equals 2t plus 1 over 4 plus 3/4 e to the 2t. Well, and again, I recommend that you verify this by hands, but since I hope by now it is pretty clear how to verify solutions of differential equations by hands, we are going to just do it by rule from alpha. Okay, so y prime equals 2y minus t, and y of 0 is 1. Are we going to get the same thing? So 1/4. So the coefficient at e to the 2t is 3/4, and the coefficient at 2t plus 1 is 1/4. So I think it's correct. Yeah, that's exactly the same thing as we got. So it's correct. Now let me do one more example in the same fashion. I'll go quicker now. Okay, so the first thing is to find the integrating factor. So the integrating factor is e to the power antiderivative of the coefficient at y. The coefficient at y is cosine t. So it is e to the sine t. Alright, so then now we need to multiply our differential equation by e to the sine t, both the left-hand side and the right-hand side. Now, from theory, we know that the left-hand side is going to be just y times the integrating factor, which is e to the sine t prime. Well, in the right-hand side is e to the 2t minus sine t plus sine t is e to the 2t. Okay, so which means that y times e to the sine t itself is going to be the antiderivative of e to the 2t, which is 1/2 e to the 2t plus constant. So y is going to be 1/2 e to the 2t plus constant times e to the minus sine t. And the question is to find the constant. And so from the initial condition, we know that the initial value of t is 0 and the initial value of y is 7. So that's substituted. 7 equals 1/2 e to the 0 is 1 plus c, and then e to the minus sine 0 is again 1. So c equals 7 minus 1/2. C equals 7 minus 1/2 is 6.5, which is 13/2. So finally y equals e to the 2t plus 13/2 times e to the minus sine t. So that's the final answer, and let us quickly verify it. This lazy method of verification by doing it in rule from alpha. So y prime plus y times cos t equals exponential function of 2 times t minus sine t, and the initial condition is y of 0 equals 7. And that's exactly the same thing as we got. Okay. Well, now finally, here is a little recap quiz for you, so you can pause the lecture and take it. And a little problem for online discussion. It is actually a very good problem, and I recommend that you try to solve it, even if you are not going to share your solution with everyone. So consider the initial value problem for a linear first order differential equation in the most general form, and just write down a ready solution